Hi, welcome back to my statistics class. So today we're going to talk about correlation. So correlation exists between two variables when the value of one variable are somehow associated with the other value of the other variable. The linear correlation coefficient, R, measures the strength of the linear correlation between the pair quantitative x and y value in the sample. So the formula of R, remember R is the linear correlation coefficient. That means R is indicator tells you that hey, these two variables, x and y, how strongly they correlated. Okay, so the formula means, remember this one means the sum, each x subtract the mean of the x times HLI, subtract the mean of y, S bar, Y bar means the mean. And then y minus 1 is the degree of freedom. And then times the S sub x means the standard deviation of x and then the standard deviation of y. Okay, I know this is really complicated. But the good news is we don't need to calculate that. We're going to use GeoGebra to find that. So remember, R is the sample linear correlation. P is the population linear correlation. Okay, so now let's talk about, I'm going to teach you how to use GeoGebra later, but let's talk about what's the R. Remember, R is the linear correlation coefficient. It's an indicator of how strong variable x correlated to y. Okay, so the value of R is between -1 and 1. So when is equals to 1? 1 means they're positive and really strongly correlated. Remember, what does a positive look like? So let's look at our previous class. Positive relation is look like this, going up. So when R is negative, it's going to down. So the value of R, it has to be between -1 to 1. And R doesn't have any units. And the closer R to -1 and 1, the stronger associative. That means when it comes to -1 and 1, or the absolute value equals to 1, close to 1, this means it's strongly correlation. At the two end, so when it comes to 0, if R equals to 0 means they don't have correlation, 0 correlation. So if R is a positive number, that means this is going to be a positive correlation. That means when x goes up, y goes up. But if it's a negative number, it means negative correlation. That means when x goes up, y goes down. So the sign of R is the direction of the association. Okay, so now let's take a look. So now how do we use GeoGebra to find our R? So first of all, there is a instruction here, but I'm going to show you. So we go to GeoGebra. So this is GeoGebra Classic. And then on the right hand, you will see a spreadsheet. You open the spreadsheet and then plug in the value, X value into the column A and Y value into the column B. So in here, let's do our previous example, that the temperature in charts. So you need to put it by yourself so you can write down the title. So remember, column A is the X value, temperature, and then B is the chops in second. So you do it one by hand. Okay. And then the next part is the chirps. Oh, I'm typing this really slow. Okay, we're done. So after you input all of the data, remember the first column, it has to be X value. The second column, it will be our Y value. So, and then we highlighted our data. So let me put this in case. This is our X, and the chirps is going to be our Y. Okay, so we highlight the data, not including the title. We just highlight the data from the second row to the bottom in here. We highlight the data and then select image of the histogram. Do you see this is the image of histogram on the upper top? We click it, we will see, hey, we choose two variable regression analysis. Since we have two variables, X and Y, and see there is our scatter plot. And then if we plug in the show statistic, if we choose show statistic, we will have the data that we need in here. The statistics, they have the mean of X, which is our X bar, and the Y bar. S of S is standard deviation of X and standard deviation of our Y. R, this is what we are looking for. What's R? R is the linear correlation coefficient. So basically it's the indicator, tells you how strong it is. And then P is the population indication. Okay, so you don't need to know the rest of the three right now. And then under it, they will have a linear model. You can choose, hey, linear model. They will give you a line, and they also give you a linear regression function. And you can also choose science. So, well, apparently this is not a science because you see that the part is quite spread out. It doesn't align to the line. And then we can also solve the power, but right now we just discussed about the linear relations. Okay, so now look at this graph. We have all the information that we need. So go back to our notes. So what's the relations between the number of chirps per second with the crickets in the weather? So we know that, hey, this is going to be a linear because you follow in line and it goes up. So it's a positive correlation. And let's look at our R. From the statistic, we found that R is equals to 0.8. 0.8 is close to 1. That means this is a strong correlation. Okay, so write a brief description of the association. So we can say the cricket chirps increases as the temperature increase. And the correlation is strong. The correlation between these two variables is strong. Okay, do these results confirm that the increase in temperature leads to a higher number of chirps from the crickets? Explain. So again, leads to, that means it's causation. Again, no. This only shows you correlation. to find out if this is causation, we need to have a controlled experiment. So these are correlated, and it doesn't tell us causation. We need a controlled experiment to find out the causation. So coefficient of determination, which is R squared. Usually you need to return in percentage. In the form of percentage. So for example, our R, let's take a look. R is equals to what? 0.81. Okay, so R squared, so we basically just square our R, 0.81 squared. So we have, let me use a calculator, 0.81 squared equals to, 0.6561. Great. Remember, R squared usually is written in percentage, so you want to write it as 65.61%. So going back to our last example, the correlation between the number of drops per second with the cracker and the temperature was R equals to 0.1345. Found the coefficient of determination. That's what we just did. And then we can write down our conclusion. So we can say, hey, about 65.61% of the variation in the crackers drops can't be explained by the temperature. So remember, R squared is the coefficient of determination. That tells you how many percentage the variable in Y can be explained by X. So it's is Y. Oops. Why would I keep writing that? I say it right, but I write it wrong. So this is Y can be explained in X. Okay, so now let's look at another example. So the data below shows the cost of the airfare and the distance traveled from each destination in Baltimore. Again, we put the data, the distance, and airfare into our GeoGebra. Okay, so I'm going to pause the video and do it by myself. So hey, I just put all of the data into our spreadsheet. So now, again, we highlighted the data we wanted to generate the scatter plot. We highlighted it and click on the icon on the upper left and choose two variable regression. And then this is our chart. After we generate it, we click on the statistic sign, which is the sum of X. We will see, hey, our X bar, Y bar, standard deviation of X, the standard deviation of Y, and R, which is 0.6953. Okay, so now let's take a look. So in our chart note, they ask you, hey, which one is the explanatory and which one is the response variable? So explanatory variable is our X, response variable is our Y. So our explanatory variable, which is independent variable, should be our distance. And the Y, the response variable, also called dependent variable, is our airfare, because the airfare is changed determined by the distance, not the other way around. So create a scatter plot for the data use technology. So we just did it. we put the data into our spreadsheet and generate a 2-variable regression analysis. Okay, so the next one is they ask you, hey, what's the correlation between the airfare and the distance of the flight? Okay, from the statistic, we found out that the R is equal to 6.6953, and this is a what? Going up, which is a positive correlation. And I would say 0.6953 would be a moderate strong correlation. Moderate strong correlated. Okay, write a brief description of the association. So we can say, hey, as the distance of the flight goes up, the cost of the airfare increases. So this is a positive correlation. So write a brief description of the association. Wow. Oh, I did it wrong. So this should be the brief description. So what's the correlation between the airfare and the distance? Which is, we just did it in here. I think I just write in the wrong places. R is equal to 0.6953 and it's a positive correlation and moderate strong. And then E is asking, hey, what's the coefficient of determination? So coefficient determination is R squared, right? So R is equals to 0.6953. And then we square it, we have 48.133%. Remember, you need to turn this into a percentage form. So, and interpret the coefficient of the determination. So we can say, hey, about 48.133% of the variation in the airfare can be explained by a variation in the distance of the flight. Okay, so that's it for today. Let me know if you have any questions.